We work on catalysis, homogeneous catalysis, mostly with metal complexes, and we strive to understand catalysis on a fundamental level and apply it to sustainable chemical technologies. So this new facility that we've built here, with support from EPSRC, the University of Bath and various industrial partners that are involved. In the first instance, we will push the boundaries of science in catalysis research. We have already made some very interesting observations that we were not able to make before using more traditional means of reaction monitoring.
I think NMR is really going to give us the opportunity to hunt down those unknown unknowns within the reactions. So in a lot of these cases, whether we're doing well-established chemistry or new chemistry, we're really looking for intermediates or byproducts that we might not necessarily see otherwise. And we might not necessarily know that they're there, we might not know that we're looking for them. So NMR is really the technique that's going to allow us to get a feel for what's going on and pick out those unknown species that we didn't necessarily know that we were hunting for.
A lot of other techniques can give you bits of information about what the atoms in the molecule might be, connections, connectivity and structure, but NMR is one of the few techniques that gives you all of that information in one place. It can also give you information about concentration as well, which other techniques can do, but are a lot more difficult to get going to do that and require lots of calibration, whereas NMR will just do it automatically.
NMR is a very powerful characterization tool. It enables you to see exactly what's going on in a reaction solution at that moment in time. So whether you take that sample and monitor it 3 minutes later, or you quench it and look at it 3 hours later, you know exactly what's in there when you've got it in the magnet.
So for us, having access to a facility like this here has really enabled us to get a much better grip on what's happening in catalysis. And in almost every reaction we've looked at so far, we've learned something new that we just weren't able to see before. It was happening in front of our eyes, but we didn't understand it, we couldn't see it. But now we can watch it, and that's exciting.